Hello ladies and gentlemen, we're going to start factoring some slightly more complicated polynomials now. So we're going to start off with sum and difference of cubes. This is something that you have seen, but it's been a little while, so let's kind of remind ourselves of the formula. Before I even do that, let me just talk about when we say list perfect cubes for reference. You need to know that these numbers are perfect cubes so that you then know, hey, maybe I can do a sum or cubes sort of factoring. So let's just kind of remind ourselves if we're trying to find some perfect cubes, like 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 64, 125, 216, 343, 512, 729, and 1000. If you don't know that those numbers are perfect cubes, then you're not going to know how to do sum or difference of cubes. So yeah, you should have those memorized and you should be able to recognize them when you see them. So the two formulas are sum and difference of cubes. Now they are the same formula. You have a cubed and b cubed. I say they're the same formula, but they're just one little tweak to them. You have a, b, a squared, ab, b squared. So they're set up the same way. The only thing that's different between these two formulas is you have a sum formula and a difference formula. There's a trick we use to remember this. If you're in the sum formula, or the difference really, you say whatever this sign is, this is going to be the same. Whatever this sign you put in is going to be the opposite, and then we say this is always positive. So the trick that we use is SOAP. It's the same thing with the minus sign. It's the same because it's minus. This will always be the opposite. So if this is minus, this is plus, this is plus, this is minus. Those are opposites. And this one's always positive. So if you can remember that, and you can remember the a, b, a squared, ab, b squared, then you've got the whole formula down. Now let's actually try and practice using it. So I wrote it up there again, just as a reminder, but we can have the same one with the minus sign. But let's go ahead and first figure out what they're cubing. If it's a cubed, then a in this problem would be the cube root of x. So that would be x. B cubed, so this is the cube root of 8, is 2. I'm going to do the signs last. So I have a and b are x and 2. A squared would be x squared. A times b is x times 2, so that's 2x. And b squared would be 2 squared, which is 4. Now I'll go back and put the signs in. So same, opposite, always positive. Now I think it's worth seeing at least once why this works. So I'm going to expand it out and kind of check my answer. X times x squared is x cubed. And then I have plus 2x squared plus 4x minus 2x squared minus 4x minus 8. And you'll notice that the middle terms all cancel out and you're just left with x cubed minus 8, which is what we were trying to get in the first place. So the reason that this formula works is because these terms all cancel out and you're just left with the first term cubed and the last term, or the, So you've got x cubed and 2 cubed. Let's do a couple more. 8 and 125 are both perfect cubes. So the first thing, you take the cube root of 8t cubed, that's 2t. And the cube root of 125 is 5. 2t squared, now you got to be careful. That's not 2t squared, it's 2t squared. 2t times itself. 2t times 2t is 4t squared. That's probably the most common mistake people make. A times b is their product, so 2t times 5 is 10t, and b squared is 25. Now I go back and put my signs in, same, opposite, always positive, and we're done. So what if you look at this third problem and you say, 648, that's not a perfect cube, I guess it can't be done. It's probably unlikely. You probably need to do GCF first. So let's say, oh wait, 3 goes into 648. So if I factor a 3 out, now I have x cubed minus 216. Let me pause it one sec. Hey, we're back. Okay, so we've got our x cubed minus 216, and what I'm going to do is, oh, that's not green, that's going to be green. Okay, now those are both perfect cubes, so I can now use my formula. The cube root of x cubed is x, the cube root of 216 is 6, and now I'm going to go ahead and say x squared. Their product is 6x, and 6 squared is 36. It's a minus, so I'm going to say same, opposite, always positive. And we did all that right, but don't forget you had your GCF of 3. That is one of your factors, so make sure you list it. 125u cubed minus 216, so those are both perfect cubes. The cube root of 125 is 5, and the cube root of 216 is 6. So again, this is the spot that I think you miss it if you're going to miss it. When you square this term, 5 squared, 5 times 5 is 25u squared. Their product is 30u, and 6 squared is 36. Again, minus, plus, plus, because it's same, opposite, always positive. Okay, so let's do a few more, just kind of knock these out. What I'm going to do is work through them, but you should hit pause. You should try and work them out, see if you can get them right, and then watch me do them. So go ahead and hit pause and work them out. Okay, now resume. Okay, here we go. Cube root was 5m, cube root is 3, 25m squared, 15m, and 9. Same, opposite, always positive. Second one, you need to do GCF first. Okay, and now we're going to take the cube root of those, so x and 5, x squared, 5x, 25. Same, opposite, always positive. You look at this one, you need a GCF as well. It's 4, and then when you bring out the 4, you have a 1 there, so 8 and 1 are both perfect cubes. The cube root of 8x cubed is 2x, the cube root of 1 is 1. 2x times 2x is 4x squared. Their product is 2x, and 1 squared is 1. This one's a sum, at least, finally, so same, opposite, always positive. That means this one will go plus, minus, plus. And last one, cube root of 27m cubed is 3m. The cube root of 1 is 1. When you square 3m, you get 9m squared. Their product is 3m, and 1 squared is 1. Same, opposite, always positive. So those are some of the difference of cubes. It's a formula. You kind of get the hang of it. I bet if I gave you 100 of them right now, you'd get them right. The question is, a week from now, will you remember the formula? So that's what you need to make sure you know all your perfect cubes and you have that formula locked down in your brain. So what else can we do? Quadratic form of a polynomial. So quadratic form, let me just kind of give you some other problems that I would solve the exact same way. If you gave me these two, I'd solve them the same way. I'm going to use all the same steps. How about I throw this one in here? Same thing. And then the one that probably would be the most like what we've seen would be this. That's a quadratic. So all of these problems are going to have the same sort of strategy for solving. We're going to do split the middle for all of them. If you gave me this problem in green, I would do GCF, I'd bring out a 2, and then I would split the middle. Well, that's what I'm going to do here, but it's a higher degree polynomial, so let me show you. First we'll do GCF. Now we have x to the 4th plus x squared minus 6. Now this is a trinomial, and we're going to split the middle. Like we always do, I'm going to find numbers that multiply to 1 times negative 6, which is negative 6, and add to the middle, which is positive 1. So the numbers that do that are positive 3x and negative 2x. But this isn't degree 1, this is degree 2, so it's 3x squared and 2x squared. When you split the middle, you're finding numbers that add to that 1, but they have to be x squareds in this problem because it's not a linear term, they're quadratic terms. So you need to make sure that they're in the right degree. You're doing the same thing with the coefficients, but you're just working with x squareds. That changes a little bit about when you're now factoring by grouping because you're going to work with, again, higher degrees. So the GCF between these two, oftentimes it's x, but here it's x squared. And now I have x squared plus 3. Bring down your minus sign. So we're factoring out a negative 2. And then you have x squared plus 3 again. So my factors are x squared minus 2, x squared plus 3, and don't forget about your 2. So it's very similar to splitting the middle, only you're working in 4th degree instead of 2nd degree. Same thing here. I need to find numbers that multiply to negative 40 and add to positive 3. So the numbers that do that are positive 8x and negative 5x. But again, these are x squareds because the middle is a quadratic. GCF between the first two terms is x squared, and I have x squared plus 8. Bring down your minus. GCF here is 5, x squared plus 8. If you distribute, you should be able to get to that previous step. And now I have x squared minus 5 and x squared plus 8. Now, when you're working with higher degree polynomials, you do need to kind of pay attention. Sometimes you're going to be able to keep going. So you need to pay attention, especially for like dots and sum and difference of cubes. These are not perfect squares. That's not a perfect square. These aren't perfect squares. So I can't do anything with these problems, but that doesn't mean I won't ever be able to do anything. Well, let's do a couple more. First thing I'm going to do is find the GCF. The GCF here is 6. So then I have x to the 4th plus 7x squared minus, let's see, what's 108 divided by 6? That'd be 54 divided by 3, so 18. Now I need to find numbers that multiply to negative 18 and add to 7. So the numbers that multiply to negative 18 and 7 are positive 9 and negative 2. Now I do GCF, x squared plus 9 minus 2, x squared plus 9, and I end up with x squared minus 2, x squared plus 9, and then don't forget your 6. Now you get to here, you're like, wait, that's dots, right? Those are both perfect squares. Wait, did you say difference of two squares? That's a sum. You can't do anything with that. Okay, you are finished. It's not factorable. If it was a minus sign, we could factor it, but we can't. One more. Let's do GCF of 2. Now I have u to the 4th minus 2u squared minus 63. So the numbers that multiply to negative 63 and add to negative 2 are positive 9 and, nope, that's backwards, negative 9 and positive 7u squared. Because you're trying to get negative 2 in the middle. So then my GCF here is u squared. Bring down your plus sign. GCF here is 7. And I have factors that are u squared minus 9, u squared plus 7, and then you bring your 2 down, and then you look, you're like, wait a minute, that is difference of squares. U squared minus 9 is u plus 3u minus 3. U squared plus 7 can't do anything. But you can keep going for some of these problems, and it is required if you are asked to completely factor. If you don't completely factor, then you didn't completely factor. Let's see what else we got. Factor quantities. So this is the last thing we'll do for this video, and then we'll start doing the rational exponents next. So factor quantities is a lot like when you're factoring by grouping. When you factor this step by grouping, you look and you see that they have that in common, and then you factor it out, and you're left with u squared plus 7 in this example. Well, we're going to do the same thing here, but they're going to be slightly more complicated. There's going to be more quantities. So first thing, recognize that you have sort of two terms here. There's a plus sign separating those two terms. Oh wait, 3, I'm sorry. 1, 2, 3. There's 3 terms in this problem. And we got to find what they all have in common, and let's first look at the coefficients. If I said factor out a GCF there, 2, 3x, and 7, you couldn't do it. Okay, never mind then. How about x minus 4s? X minus 4s, x minus 4s. Hey, they all have some x minus 4s. Now remember, this guy has x minus 4, x minus 4, x minus 4, so that's 3 of them. This guy has 3 of them, but this third term only has 2 x minus 4s. So if I say what's the GCF, you can only factor out 2 of them because they don't have 3. So I'm going to say x minus 4 squared is my GCF. Now when I factor these problems where I'm factoring out polynomials, I like to use a bracket for my GCF. You don't have to do that. In math class, though, it's the same. I think it helps keep things a little more organized, so you can do that if you want. What I'm going to do now is think, if I factor the x minus 4 squareds out, what would I be left with in each of these 3 terms? So I still have a 2, and I have 2 of the x minus 4s factored out, but I would need to multiply by another one to get degree 3. So if I were to distribute back in, I have the first term, plus I need a 3x. Now I brought one of these out, or I'm sorry, 2 of these out, but I still have one left on the inside because there should be 3. Plus 7, x plus 2, haven't done anything with him, x minus 4 squared, so I already factored those out, so I don't need to worry about them anymore. What happens in these problems, though, is you end up with something that you're going to have to simplify, because sometimes this is going to end up being factorable in the end, and you're going to have to keep going. So these problems can get really lengthy. Let's distribute 2x minus 8 plus 3x squared minus 12x plus 7x plus 14. So I'm just using distributive property, and now I will combine like terms. 3x squared. 2 minus 12 is negative 10. Negative 10 plus 7 is negative 3. Negative 8 and positive 14 make positive 6. So I have x minus 4 squared on the outside, but now on the inside I have this guy. So you have to look and say, is this factorable? And yeah, kind of. At least there's a GCF in there, so let's factor out the GCF. And you got to be careful here. The GCF is 3, but when I write it, I want to write the 3 out front because that's just how we always write coefficients. So I'm going to put the 3 out front. Now I'm factoring a 3 out of this, so I'm going to say now it's x squared minus x plus 2. And I went back to parentheses because I know I'm finished at this point. Now, this might be factorable, and if it is, you need to factor it, but in this problem, it's not. Nothing multiplies to 2 and adds to negative 1. If it was negative 2, it was a negative sign, then I could do negative 2 and positive 1, but since it's a plus, this would have to be a 3 or a negative 3. So that's it. That's completely factored. Let's try another one. You've got two terms there. So I'm going to first look for GCF, 2 and 6. Okay, GCF is 2. What else? Y plus 1s. All right, this guy's got 2, but I can only factor out 1. So y plus 1 is my GCF. Y minus 4, y minus 4. This guy has 2y minus 4, so I'm going to factor out y minus 4 squared. That's my GCF. It's polynomial. Now I'm going to figure out what I'm missing. So I factored out the 2. I factored out one of the y plus 1s, but I need another y plus 1. And I factored out both the y minus 4, so I'm good. Minus 2 times, what gives you 6? 3. Y plus 1, factored it out. Y minus 4, I need another one. Because if you multiply this times 3 times y minus 4, you will get this whole thing. Now on the inside, I'm going to simplify. I get y plus 1 minus 3y plus 12. I'm distributing. And that ends up being negative 2y plus 13, which can't do anything with that. So you just bring the GCF down, y minus 4 squared, and then that is your factored answer. Couple more. No GCF, no GCF, but I have x plus 2 quantity squared I can factor out. This guy has 2 of them, this guy has 3, so I'll factor out 2 of them. Then I'd be left with 5, and I brought those out already, plus 3x, and I have one more x plus 2 I need. Because I factored out 2 of them, but there's 3, I need to have one more on the inside. Now I will do distributive property, and I'll write my answer in standard form. 3x squared plus 6x plus 5. Is that factorable? Does anything multiply to 15 and add to 6? I don't think so. X plus 2 quantity squared. That's factored. Cool. One more and then we'll call it for this part. So, let's see. We got 2 big terms. 1, 2. Now I need to figure out what they have in common. 3 and 2. Nope. Nothing there. X plus 2 squared, x plus 2 cubed. I can bring out 2 of them. X minus 3 squared, x minus 3. I can bring out 1 of them. Okay, that's a little better. So what do I need? 3. I factored out the x plus 2s. I factored out one of the x minus 3s, but I need another. Minus 2. I factored out 2 of the x plus 2s, but I need a third. And I did factor out x minus 3, so I'm good there. Simplify the inside. 3x minus 9 minus 2x minus 4, which is x minus 13. And then I just have x plus 2. Ooh, what happened there? X plus 2 squared x minus 3. And there you go. That's completely factored. So those are factoring out binomials. The next thing we're going to do is start to factor out binomials with negative rational exponents. So it gets a little fancier, but this is a good stopping place. So make sure you have gone through all of those problems, and we're going to pick it up here in just a second with the more difficult problems.